At night, the Great Pyramid does not look like a ruin. It looks like a device waiting for a signal. Four vast faces angled toward the sky. Passages cut into darkness. Granite blocks hauled from hundreds of miles away and sealed inside a monument of almost unreasonable precision. For most archaeologists, it is the tomb complex of Pharaoh Khufu. But for modern theorists, something else lingers beneath the stone. The possibility that this pyramid was not only built to preserve a king, but to channel power. That idea is controversial. It reaches beyond the evidence, sometimes far beyond it. And yet, it survives because the pyramid itself refuses to feel simple. Its design is too deliberate to be dismissed with a shrug, and too old to answer every question we bring to it. So tonight, we begin not with a declaration, but with an investigation. We follow the stone inward, past the desert air, past the polished limestone casing that once flashed in the sun, past the descending corridor and the ascending passage, toward the granite chambers at the center of the structure. There, in narrow shafts, sealed spaces, and carefully placed blocks, later generations have found the raw material for one of the strangest modern theories ever attached to an ancient monument. Before we venture further into the shadows, take a moment to subscribe so you never miss a secret that history has tried to forget. And as we begin, leave a comment letting us know where in the world you are watching from tonight. It's a reminder of how far these forgotten echoes can reach. The question is not whether the Great Pyramid is extraordinary. That much is beyond dispute. The question is whether its extraordinary features point to a lost machine beneath the desert, or to something even more human, a civilization capable of building for eternity and leaving us unsure how to understand its silence. To begin honestly, we have to start with the explanation that most archaeologists accept. The Great Pyramid of Giza was built as a royal monument for Pharaoh Khufu, a ruler of Egypt's 4th dynasty, more than 4,000 years ago. It stood within a much larger funerary landscape. Temples, causeways, boat pits, subsidiary pyramids, mastaba tombs, and the broader sacred geography of the Giza Plateau. It was not an isolated object dropped into the desert without context. It belonged to a civilization that was deeply invested in kingship, death, rebirth, cosmic order, and the transformation of the ruler into something more than human after death. That matters, because any theory about the Great Pyramid has to pass through this landscape first. The pyramid was not simply a strange stone triangle waiting for modern engineers to decode it. It was part of Egypt's religious and political world. Earlier pyramids show experimentation over generations. Step pyramids, bent forms, collapsed or altered designs, and increasingly ambitious attempts to turn royal burial into architecture on a scale that could reshape the horizon. By the time Khufu's builders worked at Giza, Egyptian architects had already inherited a long tradition of sacred construction. They were not improvising in the dark. And yet, once we acknowledge that, the mystery does not vanish. In fact, it becomes more interesting, because the accepted explanation tells us what the Great Pyramid most likely was intended to be. It does not always explain, in a satisfying way, why every feature took the form it did, why certain engineering choices were made, or why this particular monument still feels so different from nearly everything around it. It is a tomb, according to the mainstream view, but it is a tomb of almost unnerving ambition. Its original height was around 146 meters. Its base covers more than 13 acres. It was aligned to the cardinal directions with extraordinary care, close enough that even today, with all our instruments, the accuracy invites admiration rather than dismissal. Its mass is composed of millions of limestone blocks, while its internal rooms use materials and arrangements that seem deliberately selected for strength, permanence, and perhaps symbolic meaning. The surviving passages inside are narrow, steep, and strangely austere. There are no painted walls greeting the visitor with scenes of feasting or gods. There is no grand procession of carved texts in the main chambers, no obvious decorative program to soften the severity of the place. This is one reason alternative interpretations find room to breathe. Not because archaeology has nothing to say. It has a great deal to say. But because the Great Pyramid does not behave, to the modern imagination, like a simple burial chamber. It feels too mathematical, too restrained, too mechanical in its inner spaces. Its beauty is not ornamental. It is structural. You enter through stone geometry. The descending passage drives down into the bedrock, sharply angled, like a line drawn into the earth rather than a corridor made for comfort. The ascending passage rises with the same disciplined narrowness. The grand gallery, by contrast, suddenly opens into a high, corbelled space, almost theatrical in its vertical lift, but still bare, precise, and severe. Above and beyond it lies the king's chamber, built from massive granite blocks transported from far to the south. Above that chamber are relieving spaces, also using enormous stone elements designed to redirect weight and protect the room below from the crushing pressure of the pyramid. These are not minor details. They are the features that keep the Great Pyramid alive in arguments. For Egyptologists, many of them fit within the problem of constructing a royal burial that could endure. The pyramid was designed to protect the king's body, or at least his burial equipment, and to serve as a cosmic machine in the religious sense. A structure that helped maintain the king's passage into the afterlife and affirmed divine kingship on earth. The shafts may have had symbolic connections to stars or celestial regions. The chambers may reflect changing plans, ritual functions, or architectural problem-solving during construction. The pyramid's precision may represent the Egyptian concern with Ma'at, order, balance, alignment, the proper arrangement of the world. That interpretation has depth. It is not merely they built a big tomb. It recognizes that in ancient Egypt, architecture was theology in stone. A royal monument could be political, religious, astronomical, and funerary all at once. The modern habit of demanding one function, tomb, temple, machine, observatory, can be misleading. Ancient structures often carried layered meanings. A passage might be practical during construction, symbolic after completion, and cosmological in the imagination of priests. A chamber could be physical space and sacred idea at the same time. Still, there are awkward facts that invite speculation. No confirmed mummy of Khufu has ever been found inside the Great Pyramid. The granite sarcophagus in the king's chamber was empty when it entered the historical record. The interior does not resemble the richly inscribed royal tombs of later periods. The so-called queen's chamber does not appear to have held a queen. The subterranean chamber is unfinished, or at least appears unfinished, which raises questions about planning. The internal arrangement is unusual enough that even careful scholars have proposed construction changes over time. None of this proves that the pyramid was an energy device, but it does explain why some people look at the monument and feel that the word tomb is incomplete. A tomb, after all, is a function. The Great Pyramid is also a feat of logistics. Someone had to quarry the stone. Someone had to transport it. shape it, raise it, place it, measure it, and repeat that process on a scale almost difficult to hold in the mind. Workers had to be organized, fed, housed, and directed. Ramps, sledges, levers, copper tools, stone hammers, ropes, surveying methods, administrative records. The whole apparatus of a centralized state had to converge on this one project. This is where some modern misconceptions begin. When people say, "We cannot build it today," they usually mean something more emotional than technical. Modern engineers could build a pyramid-shaped structure of comparable size, given the budget, labor, machinery, and political will. What feels impossible is not the geometry alone. It is the ancient commitment, the patience, the social machinery, the decision by an early Bronze Age kingdom to concentrate so much human effort into a single sacred object. That is astonishing enough without needing lasers from the sky. But alternative theories often begin in the gap between astonishment and explanation. The pyramid's precision becomes evidence of lost science. Its mass becomes a clue to hidden energy storage. Its chambers become resonators. Its shafts become conduits. Its granite becomes a functional component rather than a symbolic or structural choice. The entire monument is reimagined not as a tomb with unusual engineering, but as an engineered system disguised by later misunderstanding. The appeal is easy to understand. A tomb is quiet. A machine does something. A tomb preserves the dead. A machine implies a lost technology, a vanished civilization of engineers, perhaps even knowledge that could change the present if recovered. That shift turns the Great Pyramid from a monument of ancient belief into a locked device. Suddenly, every measurement might be a code, every passage an intake, every chamber a component, every absence a sign that something was removed. But this is also where caution becomes necessary. The Great Pyramid's complexity does not automatically make it technological in the modern industrial sense. Precision is not the same as electricity. Alignment is not proof of power generation. Granite does not become a circuit simply because it contains quartz. Empty chambers are not, by themselves, evidence of missing machinery. Human beings are very good at recognizing patterns, especially inside monuments that already seem larger than ordinary explanation. The more responsible question is not, could someone imagine the pyramid as a machine? Clearly they could. Many have. The better question is, what would we expect to find if it actually had functioned as one? That question changes the tone of the investigation. It moves us away from awe alone and toward evidence. A working technical system usually leaves traces, residues, wear patterns, replacement parts, access points, specialized tools, inscriptions, maintenance spaces, failed components, or later cultural memory of its operation. Not always, and not perfectly, time is not kind to anything, but enough that a claim of this scale needs more than suggestive geometry. And still, the pyramid resists being made ordinary. Even when stripped of exaggeration, it remains one of the most audacious constructions in human history. Its accepted purpose as a royal monument does not reduce it. If anything, it deepens the strangeness. The ancient Egyptians built a mountain of stone not merely to bury a king, but to bind kingship to the heavens, to transform death into order, and to make a political theology visible from miles away. That is not a small idea. So when modern theorists ask whether the Great Pyramid was something else, the honest answer is complicated. It was almost certainly not something else in the way the most extreme theories imagine. Not a power station humming with lost electrical equipment, at least not based on the evidence we currently have. But it may have been more than a tomb in the narrow modern sense. It was a sacred instrument of belief, a state project, a cosmic diagram, an architectural experiment, and a message to eternity written in mass rather than ink. The mistake is thinking that only a machine can be sophisticated. The Great Pyramid may not need hidden technology to be mysterious. Its mystery begins with the fact that a society so distant from us could organize stone, sky, labor, and royal ideology into something that still unsettles the modern mind. And within that unsettling space, one material has become especially important to those who believe the pyramid's purpose was not only spiritual, but energetic: the red granite at its core. To understand why the Great Pyramid has been reimagined as a machine, we have to move away from its outer silhouette and step into the harder, heavier, more intimate part of the structure: the granite core around the so-called King's Chamber. Most of the pyramid is limestone. That matters, because when people speak loosely about the monument, as though it were one uniform block of mysterious stone, they miss one of the most important distinctions in the entire debate. The Great Pyramid is not simply made of pyramid stone. It is a carefully organized mass of different materials, chosen for different roles. Limestone forms the overwhelming body of the monument. But deep inside, in the chambered heart of the building, the builders used granite. And not just any granite. The red granite used in the King's Chamber and the chambers above it came from the Aswan region, hundreds of miles to the south. To quarry it, shape it, transport it along the Nile, raise it into position, and fit it inside the pyramid remains one of the great logistical achievements of Old Kingdom Egypt. Even without invoking lost technology, the decision alone tells us something. This material mattered. Granite is not a soft stone. It resists the hand. It resists the chisel. It carries weight with a kind of stubborn dignity. Inside the King's Chamber, the walls, floor, ceiling beams, and the large stone coffer are all granite. Above the chamber are stacked spaces often called relieving chambers, roofed with massive granite beams, designed in the accepted interpretation to manage and redirect the crushing weight of masonry above. Whether every detail of that engineering is fully understood is another question. But the basic reason for using granite here is not difficult to grasp. It is strong. It is durable. It is prestigious. It could bear pressure where softer stone might fail. Yet this same granite has become the center of a very different interpretation. Granite contains quartz. Quartz has a real and measurable physical property called piezoelectricity. When certain crystals are squeezed, bent, or placed under mechanical stress, they can produce a small electrical charge. This is not fantasy. It is a principle used in modern technology, from quartz watches to sensors, microphones, and electronic oscillators. A quartz crystal can convert mechanical pressure into an electrical effect, and under the right conditions, it can also do the reverse, respond mechanically to an electrical signal. For modern power plant theorists, that fact is irresistible. Here is the Great Pyramid, a structure of immense weight and precision. Here is a chamber lined with granite. Here is granite containing quartz. Here is pressure, mass, perhaps vibration. The leap is tempting. Could the pyramid's granite heart have acted as a vast transducer, converting vibration into usable electrical energy? This is where the story becomes delicate, because the first part is true, and the second part is not proven. Quartz does have piezoelectric properties. Granite can contain quartz. The king's chamber is made from granite. But those facts do not automatically add up to an ancient generator. In a modern piezoelectric device, the crystal is not simply left inside a rock and surrounded by hope. It is cut, oriented, connected, insulated, and engineered into a system. The direction of the crystal matters. The shape matters. The electrodes matter. The ability to collect and use the charge matters. Granite is a mixture of minerals. Its quartz crystals are scattered through the stone in many orientations. Their tiny electrical responses, if they occur under pressure, would not necessarily combine into a clean, useful current. Many effects could cancel each other out. And even if small charges were produced under stress, there is a large difference between a measurable laboratory phenomenon and a functioning power system capable of transmitting energy. This distinction is often where the argument changes character. The alternative theory tends to begin with a valid scientific principle, then expands it into a historical claim. The scientific principle can be demonstrated. The historical claim requires evidence from the pyramid itself. Those are not the same kind of proof. Still, it is worth asking why the granite inspires such speculation in the first place. The king's chamber does feel different from the rest of the monument. It is severe, plain, and acoustically striking. Sound behaves strangely inside a closed granite room. A voice can seem to harden against the walls. A low tone may linger longer than expected. The empty coffer, sometimes called a sarcophagus, though no body has ever been found in it, has become an object of intense attention in alternative models. Some imagine it as a resonant vessel. Others see it as a component in a larger device. Its unfinished, austere presence encourages projection. It looks less like decoration than apparatus, though appearance alone is a dangerous witness. The accepted archaeological interpretation is more grounded. The chamber was probably part of Khufu's royal burial complex, even if the exact burial history remains complicated by ancient looting, later intrusion, and the absence of original funerary contents. Granite was used because it conveyed permanence and authority, and because it could support the architectural demands of the chamber. The massive beams above were not decorative indulgence. They were an engineering solution inside a mountain of stone. But power plant theorists focus on a different kind of pressure. Not only the dead weight of the pyramid, but vibration. If the pyramid somehow responded to seismic motion, acoustic energy, or internal resonance, then the granite, in their view, might have been activated. The quartz-bearing stone becomes not just a structural material, but an energetic medium. The problem is that the pyramid itself does not give us the missing steps. There is no confirmed evidence of electrodes attached to the granite. No clear wiring channels. No collection system. No inscriptions explaining electrical use. No surviving apparatus that would allow small charges to be gathered, stored, amplified, or distributed. If the chamber was a generator, it was a remarkably invisible one, at least archaeologically. And yet, dismissing the entire fascination as foolish would miss something important. The granite really does change the emotional and intellectual texture of the pyramid. It shows that the builders were not simply piling stones upward. They understood material difference. They selected limestone for mass, finer casing stone for the exterior surface, and granite for places of stress and significance. They moved stone from far away because local stone was not enough for what they wanted this interior space to be. That choice reveals sophistication, not necessarily electrical sophistication, but architectural intelligence of a high order. And sometimes the modern imagination, faced with that intelligence, reaches for the language it knows best. Machines, energy, frequency, systems. We live in a technological age, so we translate ancient achievement into technological terms. A chamber becomes a reactor. A shaft becomes a conduit. A stone box becomes a resonator. Quartz becomes circuitry. This may tell us as much about ourselves as it does about the pyramid. The more careful question is not, can quartz produce electricity? It can. The better question is there evidence that the ancient builders designed the granite chamber to exploit that property? Here, the evidence is much thinner. There is no need to deny the physics. But physics alone does not establish intention. A river can carry energy. A mountain can echo. A crystal can respond to pressure. Nature is full of effects that become technology only when someone designs a system around them. The Great Pyramid may contain materials with interesting properties, but identifying a property is not the same as identifying a purpose. Still, the granite heart remains one of the most powerful reasons the power plant theory survives. It is tangible. It is there. You do not have to invent the granite, or the quartz, or the immense pressure of the monument. They are real. What remains uncertain is the invisible architecture of the theory. The mechanism, the collection method, the intended output, the evidence of use. And so the king's chamber sits at the center of two overlapping stories. In one, it is a royal chamber built from enduring stone for a king who expected eternity to recognize his name. In another, it is the resonant core of a lost machine, its granite walls waiting to be understood not as burial architecture, but as technology. The first story rests on stronger historical ground. The second persists because the room itself feels too deliberate to be ordinary. Perhaps that is the real power of the granite chamber. It does not prove the pyramid was a generator, but it forces us to admit that the ancient builders understood weight, pressure, endurance, and material choice with a seriousness that still unsettles us. And once you stand before that kind of precision, the mind naturally begins to listen for a hum beneath the stone. To understand why the Great Pyramid became, in modern imagination, something more than a monument, we have to pause over a simple physical fact. Everything vibrates. Stone vibrates. Metal vibrates. The ground beneath our feet vibrates. A bridge, a bell, a human voice, a granite beam resting under enormous weight. All of them can respond to motion, pressure, and frequency. Most of the time, these movements are too small to notice. They are hidden inside materials, passing through them as tremors, pulses, stresses, and releases. But the principle is real. Strike the right object in the right way, and it answers. This is where the power plant theory begins to gather atmosphere. Not with lightning bolts from the pyramid's peak, not with glowing stones or impossible machinery, but with a quieter idea that the Great Pyramid may have been designed to interact with vibration itself. Supporters of this theory often point toward the pyramid's mass, its geometric precision, and its internal arrangement of passages and chambers. They imagine the monument not as a dead weight on the plateau, but as a kind of tuned structure, a stone instrument, waiting for the earth to play it. The comparison is seductive. A violin is mostly wood and air, yet under tension it can transform small motions into sound. A tuning fork is a simple piece of metal, Yet when struck, it hums at a specific frequency. Even buildings have natural frequencies. Engineers know this well. Skyscrapers sway. Bridges resonate. Earthquakes can make a structure move violently if the shaking matches the structure's own preferred rhythm. So the question becomes, could the Great Pyramid, with its immense limestone body and granite interior, have been built to respond to natural vibrations in the earth? At the cautious end of the discussion, the answer is not absurd in its smallest form. Large structures do respond to vibration. Stone transmits mechanical energy. Chambers can affect acoustics. Granite, as we have seen, contains quartz, and quartz under pressure can produce minute electrical effects. None of those statements require fantasy. They belong to physics. The difficulty comes when these modest facts are asked to carry a much heavier claim. Because to say that the pyramid responds to vibration is one thing. To say that it was intentionally engineered as an energy-harvesting device is something else entirely. The earth is not still. Beneath Egypt, as beneath every landscape, there is constant motion, distant seismic activity, thermal expansion and contraction, wind pressing against exposed surfaces, tiny ground movements invisible to the eye. Some alternative models suggest that the Great Pyramid was positioned and shaped to capture these vibrations, concentrating them through its internal passages until they reached the granite of the king's chamber. There, according to the theory, the chamber's stone components might have acted almost like transducers, converting mechanical stress into usable electrical or electromagnetic energy. It is a striking image. The pyramid as a receiver, the plateau as a foundation plate, the planet as a slow and massive generator. But real resonance is more demanding than metaphor. For resonance to become useful, several things must line up. A structure must have a natural frequency. An outside force must drive it at or near that frequency. The vibration must be strong enough, sustained enough, and directed enough to build rather than simply fade. Then, if energy is to be extracted, there must be a mechanism to collect it, transform it, and deliver it somewhere. This last step is often where the theory becomes fragile. The Great Pyramid may well have acoustic properties. Some researchers and visitors have noted that the king's chamber can produce unusual echoes and tones when sound is made inside it. The granite surfaces, hard and reflective, do not behave like soft mud brick walls. The chamber has a stern, resonant quality, as many stone rooms do. But an echo is not a power system. A hum is not proof of an ancient generator. Sound can make a space feel purposeful without revealing the purpose. There is also the matter of scale. Earthquakes carry enormous energy, but they are unpredictable and often destructive. Tiny background vibrations are more constant, but weak. A machine designed to harvest them would need some way to gather small, irregular motions and convert them efficiently. Modern engineers can build vibration energy harvesters, but these are usually small devices with carefully selected materials, conductive components, circuits, and known output pathways. They are designed around measurement, not impression. Inside the Great Pyramid, we do not find a confirmed system of this kind. There are no known coils, no identified conductive network, no preserved apparatus that clearly converts vibration into transmitted energy. No inscriptions explaining a technical operation. No residue pattern that demands an industrial reading. The internal architecture is extraordinary, but extraordinary architecture is not automatically machinery. Still, it is worth asking why the resonance idea feels so persistent. Partly, it is because the pyramid's interior does not behave like the interior of an ordinary tomb, at least not in the popular imagination. The Grand Gallery rises in a strange corbelled slope. The king's chamber is stark, almost severe. Above it are relieving chambers built with massive granite blocks, an engineering solution that seems at once practical and astonishing. The narrow shafts extend out from the chambers in ways that continue to invite debate. Nothing inside feels casual. To the ancient Egyptians, geometry, orientation, and sacred architecture mattered deeply. A royal monument was not merely a container for a body. It was a machine of meaning, a ritual landscape built in stone, aligning the king with cosmic order, solar cycles, stars, rebirth, and divine kingship. That word machine has to be used carefully. A symbolic machine is not the same thing as a mechanical power plant, but it helps explain why modern viewers sense intention everywhere. They are not wrong to sense design. The question is what kind of design they are seeing. Alternative theorists often interpret the pyramid's precision as evidence of technical function. If the builders were so exact, they argue, then perhaps every chamber, angle, and material choice served an engineered purpose. This argument has emotional force, especially because modern people tend to separate religion and technology. We imagine that if something is precise, it must be scientific in the modern sense. If it is ritual, it must be vague or decorative. Ancient Egypt does not fit that division neatly. Its sacred architecture could be mathematically disciplined without being electrical. Its builders could be practical engineers and religious thinkers at the same time. That is one of the traps in this mystery. We sometimes underestimate ancient people by assuming they could only have built such a monument if it served a hidden technological function. But we also underestimate them in another way if we treat their spiritual worldview as less intellectually serious than ours. The pyramid may encode a system of thought that is not electrical, but still highly sophisticated. The resonance theory also borrows strength from the modern language of frequency. Today, frequency has become a kind of universal explanation. We speak of radio waves, sound waves, seismic waves, brain waves, wireless signals, microwave transmission, and quantum effects, often with very different meanings, but similar vocabulary. This makes it easy for separate ideas to blend together. A stone chamber that resonates acoustically begins to feel connected to electromagnetic resonance. Quartz becomes connected to electricity. Earth tremors become connected to power generation. Each step contains a real concept, but the bridge between them may be much weaker than the words suggest. A useful comparison is the difference between hearing a wine glass ring and using it as a radio transmitter. The glass can resonate. Its vibration is real. Under the right conditions, sound can even break it. But that does not mean the glass was designed to broadcast energy across a landscape. Function depends on evidence of a system. So what can we say with more confidence? The Great Pyramid is massive enough to respond in some way to environmental vibration. Its internal chambers can produce noticeable acoustic effects. Its granite components are capable, at least in principle, of minute piezoelectric responses under stress because of their quartz content. These facts make the structure interesting to think about in physical terms. But the leap from physical responsiveness to intentional energy technology remains unproven. For the tuning device theory to move from speculation into stronger historical argument, we would need more than suggestive geometry. We would need evidence that the builders recognized and used these effects in a controlled way. We would need material traces of collection, transmission, or output. We would need a plausible operational model that survives engineering scrutiny, not only as an evocative diagram, but as a working system. And we would need to connect that model to Egyptian archaeological context. Rather than lifting the pyramid out of its civilization and placing it into a modern laboratory of imagination. This does not make the pyramid less remarkable. In some ways, it makes it more so. Because the more carefully we examine the energy theories, the more we are forced back toward the monument itself, its weight, its alignments, its stone choices, its internal discipline, its strange capacity to make modern observers feel that something has been withheld. The pyramid does not have to be a generator to be a structure of power. It already is one. Politically, spiritually, architecturally, and historically. The temptation is to listen for a hidden frequency beneath the desert, some low vibration that explains everything. But perhaps the deeper resonance is not in the stone alone. It is in the gap between what the evidence shows and what the human mind wants the pyramid to be. There is a moment in many pyramid power plant theories when the monument stops being a tomb, or even a resonant stone instrument, and becomes something stranger, a chemical apparatus. The idea is usually presented with a kind of mechanical elegance. Somewhere inside the pyramid, in one of its chambers or hidden cavities, two substances were introduced. One was hydrochloric acid. The other was zinc. When they came together, they produced hydrogen gas. That hydrogen, in the alternative model, was not an accident or a dangerous byproduct. It was the fuel, the medium, the invisible breath of the machine. At first glance, it sounds almost too modern to belong to the Old Kingdom. Acid tanks, reactive metals, gas production, controlled flow through stone passages. Yet this is exactly why the theory has such force in the imagination. It takes the pyramid's most puzzling features, chambers that seem oddly placed, shafts that are too narrow for human use, sealed spaces, polished stone, unexplained geometry, and gives them an industrial purpose. The chemistry itself is not fantasy. If zinc metal reacts with hydrochloric acid, hydrogen gas can be produced. The simplified reaction is straightforward. Zinc dissolves into solution, forming zinc chloride, while hydrogen escapes as gas. Anyone who has seen a school laboratory demonstration of metal reacting with acid knows the basic image. Fizzing, bubbles, a gas that can ignite with a sharp little pop if collected and exposed to flame. There is nothing supernatural in that, and that is part of the appeal. The chemical chamber theory borrows credibility from a real reaction. It does not begin by asking us to believe in magic. It begins with a reaction that modern chemistry can describe with confidence. The problem is not whether hydrochloric acid and zinc can produce hydrogen. They can. The problem is whether the Great Pyramid was ever built, supplied, protected, operated, and maintained as a place where that reaction was meant to occur. That is a much larger claim. In some versions of the theory, the so-called Queen's Chamber plays a central role. The name itself is misleading. There is no evidence that a queen was buried there, and the chamber remains one of the pyramid's more debated internal spaces. It sits below the king's chamber, connected to the ascending passage system, with narrow shafts extending from its north and south walls. These shafts do not behave like ordinary corridors. They are too small to move through. They were not open in the same simple way as the shafts of the king's chamber. Their purpose has been interpreted symbolically, ritually, architecturally, and by alternative theorists mechanically. For those imagining a chemical machine, such shafts become conduits. They could have carried liquids. They could have directed gas. They could have allowed reagents to enter from somewhere outside the chamber or move toward another part of the pyramid. A sealed or restricted shaft, in this reading, becomes less like a symbolic passage for the king's soul and more like a pipe in a system whose most important components have been removed or concealed. But here, the physical details begin to matter. Hydrochloric acid is not a polite substance. It does not simply sit in a limestone monument without consequences. Much of the Great Pyramid is built from limestone, which is largely calcium carbonate. Hydrochloric acid reacts readily with calcium carbonate, releasing carbon dioxide and producing soluble salts. In plain terms, acid would attack the stone. It would leave marks, alteration, residues, or at least some chemical signature if used repeatedly in quantity. A controlled chemical system would need barriers, linings, containers, channels, or materials resistant enough to prevent the structure from slowly digesting itself. That does not make the theory impossible in the abstract. Ancient people were capable of remarkable material intelligence. Egyptians worked stone, pigments, metals, ceramics, glassy materials, natron, resins, oils, and mineral compounds with great skill. They understood processes even when they did not describe them in modern chemical language. But there is a difference between practical craft chemistry and an engineered hydrogen generation plant inside a royal monument. The second requires not just knowledge of substances, but infrastructure, supply, control, containment, venting, and safety. Hydrogen is light, mobile, and highly flammable. In a confined space mixed with air in the right proportion, it can be explosive. If the pyramid were producing hydrogen intentionally, then whoever designed the system would have needed to manage flow rates, prevent unwanted ignition, separate gas from liquid, and avoid corrosive damage. They would also have needed a reason to produce hydrogen in the first place, and a second mechanism that could convert that gas into useful energy. Hydrogen alone does not make a power plant. It is a participant in a larger process. This is where the chemical theory usually joins the resonance theory. The gas, once produced, is imagined moving through the grand gallery or into the upper chambers, where vibration, acoustic energy, or some unknown transduction process would interact with the granite. In these models, the pyramid becomes a chain of linked systems: chemical reaction below, gas movement through passages, resonance in chambers, electrical or microwave energy emerging from the structure. The chemistry is not the whole machine. It is the first spark. And yet, each link in that chain has to bear weight. If hydrochloric acid was used, where was it made? How was it transported? In what concentration? In what containers? If zinc was consumed, where did the zinc come from, and in what form? Metallic zinc is not an easy material in the context of the Old Kingdom. Zinc ores exist, and zinc compounds were known in various ancient contexts. But the production and use of metallic zinc as a controlled reagent is historically complicated. Zinc has a relatively low boiling point compared with many metals, making ancient smelting difficult. The widespread production of metallic zinc belongs to much later technological histories. If a theory requires large amounts of zinc metal in Khufu's time, that requirement needs evidence, not just possibility, but traces. Those traces would not be subtle if the process operated on an industrial scale. One would expect residues of zinc compounds, especially zinc chloride or related salts, in places where the reaction occurred or where liquid waste collected. One might expect corrosion patterns, staining, mineral alteration, encrustations, or deposits in joints and surfaces. One might look for containers, basins, plugs, channels, valves, or deliberate coatings designed to manage corrosive fluid. One might also expect some archaeological hint of supply. Storage areas, tools, spent materials, inscriptions, or associated installations outside the pyramid. This is where the theory becomes delicate. The Great Pyramid has been entered, damaged, explored, robbed, restored, scanned, measured, and argued over for centuries. Its interior surfaces are not pristine. Later visitors left marks. Medieval entry points and later exploration changed parts of the monument. The absence of evidence must be handled carefully, because ancient sites rarely preserve every trace of what happened inside them. But absence is not meaningless. When a proposed function requires large-scale chemical operations, the lack of expected residues and hardware becomes a serious weakness. Some supporters respond that the machinery may have been removed in antiquity, or that the process left only faint traces, or that later contamination obscured the evidence. These are possible statements in the broadest sense, but they are not evidence by themselves. A removed machine is difficult to distinguish from a machine that never existed. A missing reservoir cannot prove a reservoir. A vanished chemical plant cannot be reconstructed simply from the strangeness of the architecture around it. The strongest version of the chemical chamber theory is not that it has been proven, but that it tries to explain features that conventional interpretation does not always make emotionally satisfying. The Queen's Chamber is enigmatic. The shafts are unusual. The internal arrangement of the pyramid is not intuitive to a modern observer. When people walk through diagrams of the monument, they often expect architecture to explain itself in practical terms. A corridor should lead somewhere. A chamber should have an obvious use. A shaft should ventilate, drain, or carry something. If it does not, the mind begins building systems. That impulse is understandable. Ancient religious architecture can be difficult for modern people because symbolic function is harder to see than mechanical function. A stone passage aligned toward the sky may seem less convincing to us than a duct carrying gas. A sealed shaft connected to cosmic belief may feel vague beside a conduit in a machine. But this preference says as much about modern imagination as it does about ancient Egypt. We live in an age of engines, networks, power grids, and hidden infrastructure. When we encounter complexity, we often instinctively ask what it powered. The archaeological view does not require every shaft and chamber to have a modern utilitarian role. In Egyptian royal monuments, architecture could be theological. Space could be ritualized. Direction, elevation, enclosure, and access could carry meaning that was not meant to serve the living body, but the transformed king. That does not solve every detail neatly, and it should not be used as a blanket answer for all uncertainty. But it reminds us that function in the ancient world did not always mean machinery. Still, the chemical theory survives because it sits in an interesting half-light. It contains a real reaction. It points toward real architectural oddities. It imagines a process that is at least chemically coherent in isolation. Its weakness is not that hydrogen chemistry is impossible. Its weakness is that the pyramid has not yielded the supporting evidence such a system should leave behind. What would change the conversation? Not a dramatic claim, but material proof. Confirmed chemical residues in meaningful locations. Evidence of acid-resistant linings. identifiable zinc byproducts tied to original construction or use, traces of controlled fluid handling, or inscriptions and tools that make technical sense in context. Even a small discovery could matter if it was specific, datable, and found where the theory predicts it should be. Without that, the chemical chamber remains an elegant reconstruction built around an absence. And perhaps that is the real lesson hidden inside this idea. The Great Pyramid invites mechanical explanations because it feels engineered beyond ordinary comprehension. But a convincing machine is not made of mystery alone. It is made of parts, wear, waste, repairs, failures, and traces of use. Chemistry always leaves a memory. So far, inside the pyramid, that memory has not spoken clearly enough. Inside the Great Pyramid, the mystery does not announce itself with decoration. There are no painted walls guiding the visitor through a royal biography, no long ceremonial texts explaining what each corridor was meant to do, no helpful inscriptions saying, in effect, "This is why we built it." And instead, the pyramid gives us geometry, pressure, slope, stone, and absence. It communicates through architecture more than language, which is partly why so many different stories have been projected onto it. The passage system is strangely compelling because it feels both simple and difficult to explain. A descending corridor plunges into the bedrock beneath the monument. An ascending passage rises toward the interior. The grand gallery stretches upward with a kind of severe elegance, its corbelled walls narrowing overhead. Beyond it lies the chamber traditionally called the King's Chamber, built from massive granite blocks. Lower in the structure is the chamber often called the Queen's Chamber, a name given much later and not necessarily connected to its original purpose. Then there are the shafts. They are small, narrow, and awkward. Some rise from the King's Chamber toward the outer surface of the pyramid. Others begin in the Queen's Chamber, but do not appear to open cleanly to the outside. They are too cramped for human passage, too carefully made to dismiss as accidental gaps, and too unusual to ignore. Their existence is one of the reasons the Great Pyramid has never quite settled into being only a monument in the public imagination. The most cautious interpretation is that these shafts had symbolic or ritual meaning. In Egyptian royal belief, the king's afterlife was not merely a vague journey into another world. It was connected to the sky, to stars, to solar rebirth, and to the transformation of the dead ruler into a divine or semi-divine being. Some researchers have argued that certain shafts may have been aligned toward significant celestial regions as they appeared in the ancient sky, perhaps connected with circumpolar stars, Orion or Sirius. The details are debated, partly because alignments depend on the date, the exact angle, and how much intention we are willing to infer from architecture. But the broader idea is not unreasonable. Egyptian monuments often expressed cosmic order through stone. Temples, tombs, causeways, and pyramids were not just buildings. They were structured environments, built to mediate between earth, kingship, gods, and the heavens. If the shafts symbolically opened a route for the king's spirit, their narrowness would not be a problem. A soul does not require comfortable headroom. Another practical interpretation is ventilation. The shafts connected to the king's chamber do reach outward, and to early explorers, it was natural to describe them as air channels. In a modern sense, however, ventilation is an awkward explanation. The pyramid was not designed as a living space. The chambers were not meant to host a permanent workforce, and after sealing, air circulation would have had little practical purpose. Still, construction phase ventilation cannot be entirely dismissed. Workers inside deep stone passages would have needed air, and the inner spaces may have required some means of managing heat, humidity, or dust during construction. The problem is that this explanation fits some shafts better than others. The Queen's Chamber shafts, for example, were originally sealed behind the chamber walls and do not present themselves as ordinary air ducts. This is where alternative theories find their opening. When a feature looks engineered but resists a simple explanation, it becomes tempting to ask whether it belonged to a system we no longer understand. In power plant models, the shafts and passages are not symbolic routes or builder conveniences. They become conduits. They become channels for chemicals, gases, acoustic waves, or electromagnetic effects. The descending passage and subterranean chamber may be interpreted as part of an intake or reaction zone. The Queen's Chamber may be imagined as a chemical chamber. The shafts may be described as supply lines, pressure vents, waveguides, or directional components in a larger energy-generating mechanism. The Grand Gallery, with its long sloping form and repeated slots or features along its sides, is sometimes reimagined as a resonant hall, a space where vibrations could be intensified or controlled. There is a certain narrative elegance to this theory. It takes details that seem unrelated and links them into one machine-like sequence. A sealed chamber becomes intentional containment. A narrow shaft becomes a technical duct. An angled corridor becomes a tuned pathway. Granite becomes a transducer. The pyramid's geometry becomes not ritual order, but engineering design. The difficulty is that elegance is not the same as evidence. A real conduit system usually leaves traces of what moved through it. If chemicals pass through the shafts, we might expect residue, corrosion patterns, mineral deposits, staining, erosion, or modifications suited to repeated flow. If gases were generated and controlled, we might expect mechanisms for sealing, regulating pressure, or safely releasing byproducts. If the shafts acted as waveguides in an electromagnetic sense, their dimensions, materials, and terminations would need to match the behavior being claimed, not just appear narrow and mysterious. In engineering, shape matters, but so does context. A tube is not automatically a pipe. A chamber is not automatically a reactor. The Queen's Chamber shafts are especially important here because they have been used heavily in alternative reconstructions. They were not open to the chamber when the pyramid was first entered in modern times. They were discovered behind the walls in the 19th century. Later, robotic investigations explored them further and found small blocking stones, sometimes described as doors, with metal fittings. These discoveries understandably excited the public imagination. A sealed shaft ending in a small stone barrier feels like a deliberate secret. It has the quiet drama of something waiting just beyond reach. But again, caution matters. The presence of a blocking stone does not automatically mean a hidden machine. Egyptian builders sealed, blocked, adjusted, and concealed architectural features for many reasons, including ritual closure, construction sequence, symbolic design, or changes in plan. The metal fittings are intriguing, but they are not evidence of wiring in the modern electrical sense. Copper in ancient Egypt was common and useful. It could serve practical, symbolic, or construction-related roles without implying an electrical circuit. The idea of shafts as waveguides also needs careful handling. In modern physics and engineering, a waveguide is not just any passage through which energy might travel. It is designed according to the wavelength, frequency, material boundaries, and losses involved. A passage can guide sound differently from how it guides microwave radiation. A stone corridor may carry acoustic reverberation, but that does not mean it is optimized for controlled energy transmission. The Great Pyramid certainly has acoustic properties. Many stone spaces do. Granite chambers can resonate under certain conditions. Long passages can shape echoes. But turning resonance into purposeful power generation requires a chain of evidence that has not been found. This is one of the quiet traps in interpreting ancient structures. When something is precise, we assume it must be precise for the reason that interests us. The pyramid's builders were clearly capable of extraordinary planning. The internal passages were measured, angled, and integrated into a colossal mass of masonry. That fact deserves respect. But precision does not identify function by itself. A ritual structure can be precise. A symbolic passage can be exact. A tomb can be engineered with astonishing care. Sacred architecture is not careless architecture. At the same time, dismissing every unusual feature as symbolic can become too easy. Symbolism should not be used as a storage cupboard for anything we do not understand. The shafts are real architectural decisions. They required labor. They required planning. Their angles and placements were not random. Whether they carried air, pointed toward stars, served ritual purposes, helped with construction, or reflected a design change, they were part of how the builders imagined the pyramid's inner life. The more interesting question may not be whether the shafts were practical or symbolic, but whether that division is modern. Ancient Egyptian builders did not necessarily separate function, ritual, astronomy, and kingship into the neat categories we prefer. A passage could be physically constructed, cosmologically meaningful, and ritually necessary all at once. A shaft might work not because it carried gas or electricity, but because it connected the king's chamber to a celestial order that was, for them, completely real. This is where the power plant theory both fascinates and falters. It recognizes that the pyramid's interior feels designed rather than incidental. It pays attention to geometry, material, angle, and enclosure. In that sense, it is responding to something genuine. The Great Pyramid does feel like an object of intention. But the theory often moves too quickly from intention to technology, and from technology to a specific modern kind of technology. What we can say with more confidence is that the shafts and passages remain among the most important clues to the pyramid's purpose. They show that the monument was not merely a pile of stone surrounding a burial space. It had an internal architecture of movement, direction, separation, and access. Some routes were open. Some were blocked. Some led upward. Some descended into the earth. Some connected chambers to the outside world, or seemed to reach toward it without fully arriving. That complexity is enough to keep the debate alive without forcing the evidence to say more than it can. The shafts may not prove an ancient energy system, but they do prove that the Great Pyramid was conceived with an interior logic still not fully understood. And perhaps that is why they remain so powerful in the imagination. Because they are small, almost hidden features inside one of the largest monuments ever built. And they remind us that the deepest mysteries are not always found in grand surfaces. Sometimes they are found in narrow passages, angled through stone, refusing to explain themselves. The most ambitious version of the pyramid power theory does not imagine the Great Pyramid as a simple battery, or a symbolic amplifier, or a strange stone antenna humming quietly beneath the desert sky. It imagines something much more elaborate, a complete energy system built into the monument's architecture, using chemistry, acoustics, mineral physics, and geometry together. In this interpretation, the pyramid is not merely a tomb that later generations misunderstood. It is a machine whose moving parts were not gears or pistons, but gases, vibrations, stone, pressure, and carefully shaped internal spaces. The theory, in its most developed form, usually begins below the main chambers, in the descending passage and subterranean chamber. Alternative researchers have proposed that chemicals were introduced into the pyramid, possibly through shafts or corridors, to create hydrogen gas. The usual reaction suggested is between hydrochloric acid and zinc, which can indeed produce hydrogen. That part, as chemistry, is real. If zinc reacts with hydrochloric acid, hydrogen gas is released. No mystery there. Any student in a laboratory can demonstrate the principle, preferably with better ventilation and less ambition than turning a royal monument into an ancient power station. From there, the hypothesis becomes more intricate. The hydrogen gas, according to the model, would move upward through the internal passage system. The Grand Gallery, with its high corbelled ceiling and unusual shape, is often described by proponents as more than a ceremonial corridor. It becomes, in their reconstruction, a resonant hall, a kind of acoustic or mechanical amplifier. Some versions suggest that the Grand Gallery once held tuning devices or resonators, possibly removed in antiquity. Others argue that its dimensions alone could have shaped vibration, guiding energy toward the upper chambers. Then comes the King's Chamber, built from massive blocks of red Aswan granite. This is where the theory leans heavily on quartz. Granite contains quartz crystals, and quartz is piezoelectric. Under mechanical stress, it can generate tiny electrical charges. In modern technology, quartz is used in watches, radios, sensors, and oscillators, not because it produces magical power, but because it can respond to pressure and vibration in precise and measurable ways. The pyramid power plant model takes this property and scales it up. It suggests that vibrations from the earth, from sound, or from moving gas place the granite under rhythmic stress. That stress, acting on quartz within the stone, allegedly produced electrical effects. These effects, in turn, interacted with the hydrogen inside the chamber. Some versions of the hypothesis propose that the chamber became a kind of microwave cavity, where electromagnetic energy was amplified and directed through one of the shafts. This is the point where the theory becomes both fascinating and fragile, because, on paper, several ingredients sound as though they belong in the same conversation. Hydrogen can interact with electromagnetic radiation. Cavities can resonate at particular frequencies. Quartz can convert mechanical stress into electrical charge. Stone chambers can transmit and reflect sound. Geometry can influence resonance. These are not fictional concepts. They are real principles from chemistry, physics, and engineering. But placing real principles side by side is not the same as demonstrating that an ancient structure was built to combine them into a functioning power plant. A microwave generator is not just a room where hydrogen, stone, and vibration happen to coexist. It requires a controlled source of energy, a method of excitation, conductive or reflective boundaries suited to the intended frequency, a way to maintain stable conditions, and usually components designed with extreme precision for electromagnetic behavior. In modern terms, one thinks of magnetrons, waveguides, cavities, power supplies, insulators, cooling systems, and materials chosen because their electrical properties are understood and controlled. The Great Pyramid gives us something different. It gives us passages, chambers, shafts, granite, limestone, sealed spaces, and an astonishing command of mass and alignment. It gives us architectural discipline, not obvious technical apparatus. Proponents sometimes respond that the machinery was removed, or that the pyramid's architecture itself was the machinery. This is an important distinction. If the claim is that detachable components once existed and were later stripped away, then we would expect at least some traces. Anchor points, tool marks with specific mechanical purpose, chemical staining, residues, corrosion patterns, deposits from repeated reactions, unusual wear, or technical debris hidden in cracks and joints. If the claim is instead that no separate machinery was needed, then the burden shifts to showing that the remaining stone structure alone could perform the necessary work. That is a difficult case to make. The king's chamber, for example, is often compared to a resonant cavity. In a loose poetic sense, any enclosed space can resonate. Clap your hands in a stairwell, sing in a tiled bathroom, speak beneath a dome, and the shape of the enclosure changes what you hear. But electromagnetic resonance, especially at microwave frequencies, is not the same thing as an echo in a chamber. Microwave cavities must be shaped and surfaced in ways that control electromagnetic waves, and their dimensions are tied to particular wavelengths. Granite and limestone are not impossible materials to discuss in electromagnetic terms, but they do not behave like polished conductive metal chambers used in modern microwave systems. There is also the question of energy output. Piezoelectric effects in quartz-bearing granite can be measured, but they are generally small. To extract useful power, one would need organized stress across crystals, electrodes, or conductive pathways to collect charge, and a circuit capable of using it. Random quartz grains embedded in granite are not aligned like engineered quartz components. They do not conveniently join forces because a theory asks them to. Nature is often generous with hints, but less generous with efficiency. The hydrogen element creates another challenge. Hydrogen is not, by itself, a power source in the way casual descriptions sometimes imply. It can store or release energy under certain conditions, and it can be produced through chemical reactions, but producing it with acid and metal consumes materials. If the Great Pyramid functioned as a hydrogen-based energy system, it would require a supply chain. Acid, reactive metal, containers, channels, control mechanisms, safety measures, and a purpose for the gas once produced. A working system would have left behind not only architecture, but an industrial footprint. And yet, the hypothesis survives partly because it identifies genuine oddities in the building. The Great Pyramid is not an ordinary pile of stone. The internal arrangement is strange, even when viewed through orthodox Egyptology. The descending passage leads into a rough subterranean chamber whose purpose remains debated. The so-called Queen's Chamber has shafts that do not open fully to the exterior in the same way as the upper shafts. The Grand Gallery is unlike almost anything else in Egyptian architecture. The King's Chamber uses granite in a way that feels deliberately concentrated and technically demanding. Above it, the relieving chambers distribute weight with enormous blocks hauled from far away. These details do not prove an energy machine, but they help explain why the machine theory found fertile ground. The pyramid's interior feels too intentional to be dismissed as random, yet too unusual to be easily explained in every detail. Into that gap, modern imagination brings the language of physics. This is where a careful investigation has to separate three different questions that are often blended together. First, could the materials of the pyramid participate in physical effects such as vibration, electrical charge, or resonance? In a limited sense, yes. Second, did the builders know these effects and design the pyramid to exploit them? That is far less certain. Third, did the pyramid function as a microwave power plant capable of transmitting useful energy? There, the evidence becomes thin. The theory often gains power by moving quickly from one question to the next, as if each maybe quietly becomes a therefore. Quartz can be piezoelectric. Therefore, granite may produce charge. Therefore, the chamber may amplify energy. Therefore, hydrogen may be excited. Therefore, microwaves may be generated. Therefore, the shafts may transmit power. It is a chain of possibilities, but a chain is only as strong as the links that can actually bear weight. The most responsible way to approach it is not to laugh it away, nor to embrace it because it sounds grand. It is to ask what the theory predicts. If hydrogen was produced, where are the chemical traces? If zinc was used in quantity, where did it come from, and where are the residues? If microwaves were generated, what materials acted as conductors, reflectors, or collectors? If energy was transmitted, to what receiver? If the system was central to the pyramid's purpose, why do Egyptian inscriptions, tools, tomb culture, and surrounding archaeological evidence point so strongly toward royal ideology, ritual, and kingship instead? None of these questions destroys the wonder of the pyramid. In a way, they sharpen it. The power plant hypothesis is compelling because it tries to treat the pyramid as an engineering object rather than only a religious monument. That instinct is not foolish. The Great Pyramid is engineering. It is planning, quarrying, hauling, measuring, leveling, organizing, and aligning on a scale that still commands respect. But engineering does not have to mean electricity. Precision does not automatically imply lost technology. A structure can be mathematically elegant, materially sophisticated, and symbolically profound without being a machine in the modern industrial sense. The microwave power plant theory tells us as much about our age as it does about the old kingdom. We live in a world where invisible energy moves through antennas, satellites, wires, towers, and devices small enough to vanish in a pocket. So when we encounter an ancient monument whose purpose is not fully transparent, we translate it into the language we understand. Frequency, transmission, resonance, power. Perhaps that is why the idea refuses to feel absurd at first glance. The pyramid already looks like a device. It is too clean a shape, too deliberate against the horizon. But resemblance is not evidence. A pyramid can look like an antenna without behaving like one. What remains, then, is a theory built from real science, arranged into a speculative architecture, and placed inside one of the most enigmatic monuments ever made. It is not impossible because quartz is fake, or resonance is fake, or hydrogen chemistry is fake. Those things are real. The uncertainty lies in whether they were ever brought together here, deliberately, by the builders of Khufu's pyramid, for the purpose of generating and transmitting energy. At the moment, the stones themselves do not say that. They say something quieter, and perhaps more difficult, that ancient people could marshal knowledge, labor, belief, and authority into a form so enduring that thousands of years later, we still struggle to decide where architecture ends and imagination begins. There is a moment in almost every theory of the Great Pyramid as a power plant when the imagination becomes beautifully engineered. Hydrogen moves through hidden roots. Granite vibrates. Quartz responds under pressure. The chambers become resonators. The shafts become conduits. And the whole monument begins to resemble not a tomb, but an instrument built on a scale that makes modern machinery feel almost small. And then comes the colder question. Where is the machine? Not the stone body of it. Not the geometry. Not the mass. Not the suggestive alignments or the strange internal spaces. Those are real, and they deserve careful attention. The question is more specific. If the Great Pyramid was designed to produce, control, amplify, transmit, or distribute energy, where are the parts that would make such a system more than an architectural possibility? Because machines leave habits behind. They leave scars. They leave residues. They leave repairs, replacements, fittings, sockets, stains, tools, waste products, discarded components, and technical language. Even when the valuable pieces are stripped away, the negative spaces often remain. A vanished door leaves pivot holes, a removed statue leaves a base, a dismantled furnace leaves slag, discoloration, fuel traces, and changes in the surrounding material. Ancient industry, even when ruined, is rarely as clean as an idea. This is where the power plant hypothesis enters its most difficult terrain. Not because every unexplained feature has been explained away. It has not. The Great Pyramid still contains engineering choices that invite debate. But because the stronger the proposed technology becomes, the more evidence it should require. A symbolic chamber can be bare. A royal monument can be austere. A ritual passage can end in an unexpected place. But an industrial energy system needs interfaces. It needs points of contact between material and process. If chemicals were introduced, stored, and reacted, there should be some indication of containers, channels, mineral alteration, corrosion, or repeated maintenance. If electrical current was collected or directed, we would expect evidence of conductors, electrodes, terminals, insulating materials, or at least fixtures for holding such things in place. If electromagnetic waves were shaped or transmitted, then the theory has to account for components that do the shaping and transmitting. The pyramid, as we know it, has not yielded confirmed examples of these. No verified electrodes have been found in the chambers. No chemical reservoirs have been identified as part of an ancient reactive system. No known wiring network appears in the masonry. No confirmed lenses, insulators, wave-guiding devices, switches, or technical fittings have been recovered from the structure. There are no inscriptions inside the pyramid explaining an electrical mechanism. No diagrams showing energy flow. No administrative records. So far as the evidence stands, describing the movement of acids, metals, or specialized machine parts into the monument. This does not mean every stone has surrendered every secret. It does mean that a theory requiring an advanced operational system must confront an unusually clean archaeological record. Supporters of alternative interpretations sometimes answer this problem by pointing to loss. The pyramid was entered in antiquity. It was damaged. Its casing stones were removed over time. Valuable objects could have been taken. Metals, especially useful metals, are precisely the kind of material later people would strip out and reuse. That is a reasonable caution. Ancient monuments have often been robbed, repurposed, and misunderstood by later generations. We should not pretend that what survives is the whole story. But removal is not a magic solvent. It cannot dissolve every trace equally. If a machine once occupied the king's chamber, for example, and if that machine required fixed contact with the granite, we might expect sockets, wear patterns, mounting marks, or altered surfaces consistent with attachment. If chambers held reactive chemicals in meaningful quantities, especially substances as aggressive as strong acids, we would look for chemical signatures on stone, unusual staining, etched surfaces, deposits, or corrosion products in places that match the proposed operation. If metal components were repeatedly installed and removed, there might be abrasion or residues at the points of use. If the system produced gas, pressure, heat, or vibration at industrial levels, the internal architecture would likely show signs of adaptation to those stresses. The absence of such evidence is not dramatic. It is not cinematic. It is simply stubborn. And it matters. One of the easiest mistakes in pyramid speculation is to treat stone as if it were machinery by default. Granite becomes a transducer because it contains quartz. Shafts become ducts because they are narrow. Chambers become reactors because they are enclosed. Alignment becomes circuitry because it is precise. In that style of thinking, resemblance begins to do the work of proof. Yet, archaeology moves differently. It asks not only, could this feature be imagined as part of a machine, but what would we expect to find if it were one? That second question is less glamorous, but far more useful. It turns a theory from a drawing into a testable claim. Consider the so-called missing components not as a single absence, but as a whole pattern of absences. No clear electrodes, no confirmed chemical apparatus, no industrial residue, no written technical tradition attached to the pyramid, no workshop debris directly connected to a power system, no control mechanisms, no distribution infrastructure, no receiving devices, no downstream technology that clearly depends on pyramid-generated energy. This last point is easy to overlook. A power plant does not exist in isolation. It belongs to a world of use. If energy was being generated at Giza, who used it? Where did it go? What devices consumed it? What industries were transformed by it? Where are the lamps, motors, transmitters, instruments, or specialized tools that would make sense of such a source? Ancient Egypt was an astonishingly capable civilization. It organized labor, quarried stone, moved colossal blocks, surveyed land, measured time, administered harvests, crafted jewelry of extraordinary delicacy, and built monuments that still dominate the human imagination. But the material culture we have from Egypt does not show an electrical civilization hiding behind the stonework. It shows a complex Bronze Age world with advanced architecture, mathematics in practical form, religious symbolism, state organization, and skilled craftsmanship. That is not a dismissal. In many ways, it is more impressive than the fantasy, because it does not require the civilization to be secretly modern in order to be magnificent. Still, the missing machinery problem should not be used as a blunt weapon. There is a lazy version of skepticism that says, "We have not found it, therefore it never existed," and then stops thinking. That is not good history either. Absence of evidence is not always evidence of absence. Preservation is uneven. Excavation is incomplete. Interpretations change. Archaeologists have been surprised many times by objects found in places where no one expected them. But absence becomes meaningful when evidence should be durable, repeated, and structurally necessary. If someone claims a wooden ritual object once stood in a chamber and was removed in antiquity, the lack of survival may not be surprising. Wood decays. Portable objects vanish. If someone claims a vast stone monument functioned as a chemical electrical resonant power system, the missing evidence is harder to wave away because the claim involves processes that should have interacted with the building itself. Such a system would not simply sit inside the pyramid like furniture. It would use the pyramid. It would mark it. That distinction is essential. The Great Pyramid's internal design is strange enough without forcing it into the shape of an engine. The descending passage, the ascending passage, the grand gallery, the so-called Queen's Chamber, the King's Chamber, the relieving chambers above it, and the narrow shafts all form a structure unlike a simple burial room. Their purposes remain debated in places, and some details may never be fully resolved. But mystery is not empty space waiting for machinery. It is a boundary between what the evidence shows and what our minds are tempted to complete. There is also a psychological reason the missing machinery is so easily overlooked. Stone survives better than context. We stand before the pyramid and see mass, precision, and endurance. We do not see the vanished labor villages in the same immediate way. We do not feel the administrative systems, the food supplies, the quarry logistics, the rope, copper tools, sledges, ramps or ramp-like systems, human coordination, and generations of accumulated building knowledge. The monument looks inhuman because most of the human process has disappeared. A machine theory offers a different kind of satisfaction. It says the strangeness is not the result of lost labor systems or religious ambition, but of hidden technology. It makes the pyramid legible to a modern mind trained to recognize devices. A chamber must have a function in the mechanical sense. A shaft must carry something measurable. A resonance must be harvested. The building becomes less like a monument to kingship and eternity, and more like a device waiting for its patent diagram. But ancient architecture often had functions that were not mechanical, yet were not meaningless. Symbolic function is still function. Ritual space can be precise. Cosmic alignment can be intentional without being electrical. A passage can guide a soul, a ceremony, a royal transformation, or a theological idea, even if it never carried gas or current. To modern viewers, that can feel unsatisfying because it leaves no switch to flip. But to the people who built the pyramid, the invisible order of the cosmos may have been as real and urgent as any technology. The strongest version of skepticism, then, is not mockery, it is proportion. Piezoelectricity is real, but real effects require real conditions. Chemical reactions are real, but real reactions leave real traces. Resonance is real, but not every resonant space is an engine. Precision is real, but precision alone does not identify purpose. The Great Pyramid can be an engineering marvel without being a power plant, and yet, even after the missing machinery is acknowledged, the building does not become ordinary. If anything, the debate reveals something more interesting. The pyramid is so controlled, so immense, and so resistant to simple explanation that later ages keep trying to upgrade it into the highest technology they can imagine. In one century, it becomes a storehouse of sacred measurements. In another, a prophetic monument. In another, an energy device. Each age looks into its passages and finds a reflection of its own obsessions. For our age, that obsession is power, clean power, hidden power, wireless power, suppressed power, ancient power. so we search the king's chamber for the ghost of a machine. What we find instead is a harder kind of mystery. Not a missing generator, at least not one supported by the evidence so far, but a civilization capable of turning stone, labor, belief, and royal authority into something that still behaves like a question after 4,500 years. The machinery may be missing because it was removed. It may be missing because we have not recognized it. But the more cautious answer is also the most demanding. It may be missing because it was never there. And if that is true, the Great Pyramid does not become less extraordinary. It becomes extraordinary in a way that belongs more fully to the ancient world that made it. At a certain point, the Great Pyramid theory leaves Egypt. It crosses the desert, moves backward and sideways through time, and begins gathering other ancient worlds into its orbit. Sumer, Akkad, Babylon, the high plains of Mesoamerica, the stone circles of Britain, the Nazca lines in Peru. Suddenly, Khufu's monument is no longer only a structure on the Giza plateau. It becomes one node in a planetary system, a buried circuit, a wireless grid, a navigation network for beings who came from somewhere beyond Earth. This is where the Anunnaki enter the story. The Anunnaki were not Egyptian. That matters more than it may first appear. In the ancient Mesopotamian world, the Anunnaki belonged to the religious imagination of Sumer, Akkad, Assyria, and Babylon. They appear in myths, temple traditions, king lists, and cosmological stories as powerful divine beings associated with heaven, earth, judgment, kingship, and the deep ordering of the universe. Their roles changed over time, as divine roles often do. Ancient religions were not fixed manuals. They were living systems, reshaped by cities, dynasties, scribes, and priests. But in modern alternative history, the Anunnaki have been reimagined as something very different. Extraterrestrial engineers, ancient colonizers, or advanced visitors who shaped human civilization. In that version, the gods of Mesopotamian myth become flesh and blood beings from another world. Their temples become technical installations. Their rituals become misunderstood science. Their myths become encoded reports of contact. From there, it is only a short leap, at least narratively, to connect them with the pyramids. The idea usually works like this. If the Great Pyramid was not merely a tomb, and if its inner chambers were part of an energy system, then perhaps it was not an isolated machine. Perhaps it belonged to a larger design. The pyramid's geometry, its orientation, and its placement on Earth become clues. Other ancient monuments are then added to the map. Pyramids in Egypt, ziggurats in Mesopotamia, temples in Central America, megalithic sites in Europe, and mysterious lines or earthworks across the world are treated as pieces of one ancient technological network. In some versions, this network transmitted wireless power. In others, it stabilized Earth's energies, marked planetary ley lines, guided spacecraft, or served as a navigation and communication grid for beings in orbit. It is an enormous idea. That is part of its appeal. There is something intoxicating about looking at Earth from above and imagining a hidden pattern beneath the scatter of monuments. A temple here, a pyramid there, a stone circle on a windswept plain, a mountain sanctuary aligned with the sun. The human mind wants connection. It has always wanted connection. We look at stars and make constellations. We look at ruins and make systems. Sometimes that instinct leads to genuine discovery. Sometimes it creates patterns that say more about us than about the past. The global grid theory depends heavily on the feeling that ancient builders were all participating in the same secret project. Yet the first difficulty is cultural. The Anunnaki belong to Mesopotamian texts, not to Old Kingdom Egyptian inscriptions. The Great Pyramid belongs to the reign of Khufu in the 4th dynasty, within a specific Egyptian religious and political world. Its construction, labor organization, quarrying methods, royal symbolism, and mortuary context are tied to Egypt. To connect it directly to the Anunnaki requires more than noticing that both cultures built impressive monuments. It would require evidence of contact, shared technical language, inscriptions, artifacts, or transmission of ideas in a way that can be traced. The evidence for that direct connection is not there. That does not mean Egypt and Mesopotamia existed in sealed glass boxes. Ancient cultures interacted. Trade routes, materials, artistic ideas, and religious motifs could travel astonishing distances over long periods of time. But interaction is not the same as a single hidden technological command structure. A lapis lazuli trade route does not prove an interplanetary engineering project. A similarity in monumentality does not prove common extraterrestrial authorship. Ancient people across the world built upward because height has obvious symbolic power. It brings the ruler, the priest, the dead, or the sacred closer to the sky. It makes authority visible. It turns labor into landscape. The pyramid shape itself is not as mysterious as it sometimes appears. It is stable. It distributes weight efficiently. It can be built with available materials and human organization. It also carries immense symbolic force. A mountain made by people. A horizon line turned into architecture. A stairway for the royal dead. Or a stone statement that the king's order would outlast the bodies of those who served him. Different cultures arrived at pyramid-like forms for different reasons, and often under very different circumstances. Egyptian pyramids are not the same as Mesopotamian ziggurats, and neither is the same as Maya temple pyramids. They may look related from a satellite image or a coffee table photograph. On the ground, in their rituals, construction, and meaning, they belong to separate worlds. The global grid idea often smooths away those differences. It turns varied human traditions into one diagram. That flattening is one of the quiet problems with ancient astronaut theories. They frequently claim to honor ancient civilizations by saying they possessed hidden, advanced knowledge. But they can also take away the very thing that makes those civilizations interesting, their distinctiveness. The Egyptian vision of kingship was not the same as the Mesopotamian view of divine authority. A ziggurat was not simply a pyramid under another name. A temple platform in Uruk, a royal pyramid at Giza, and a stepped pyramid in Mesoamerica were shaped by different languages, economies, landscapes, gods, and political needs. If all of them become components in an alien power grid, the details begin to disappear. And yet, the theory survives because it offers a kind of elegant grandness. It explains many mysteries at once. Too many, perhaps. A difficult stone alignment? Part of the grid. A monument built with impressive precision? Part of the grid. A myth about sky beings. Evidence of visitors. A lack of machinery? The technology was removed, hidden, or beyond our current understanding. This is not how careful historical reconstruction usually works. Good evidence narrows possibilities. It does not endlessly expand them. Still, it is worth asking why people find the global grid so compelling. Part of the answer lies in modern technology itself. We live in a world of invisible systems. Signals pass through walls. Satellites guide cars through unfamiliar cities. Wireless networks turn air into infrastructure. Energy grids connect distant places we never see. To us, the idea of an invisible planetary network feels natural. It is one of the defining experiences of modern life. So when we look back at ancient monuments with precise alignments and astronomical references, it is tempting to imagine that they were doing something similar in a lost language of stone. But ancient alignment is not automatically ancient telecommunications. Many Egyptian monuments were aligned with celestial, solar, or cardinal principles because the sky mattered religiously and politically. Orientation could express order. It could anchor the king within cosmic cycles. It could connect architecture to dawn, sunset, stars, the Nile, and the Egyptian understanding of renewal. That is not a lesser explanation. In fact, it may be more profound than the mechanical one. A culture does not need wires to build with cosmic intention. It needs a worldview in which the cosmos is not background, but authority. The Anunnaki extension also often relies on a selective reading of myth. Mesopotamian texts are poetic, complex, and layered. They speak of gods descending, councils in heaven, divine decrees, created humans, catastrophic floods, and kingship granted from above. Modern readers, trained by science fiction and space travel, can easily translate heaven into outer space, gods into aliens, and divine craft into technology. But translation is not interpretation. Ancient words lived inside ancient assumptions. The sky was divine not because it hid spacecraft, but because it was vast, ordered, terrifying, fertile, and unreachable. Of course, myth can preserve memories. Flood stories may echo real experiences of devastating inundation. Tales of divine kingship may preserve social transformations. But to move from myth may encode memory to myth records extraterrestrial engineering is a very large step. The evidence is thinner here, and it becomes thinner still when those Mesopotamian stories are attached to Egyptian pyramids without a clear historical bridge. The global grid theory also has a technical weakness. If the pyramids and other monuments were parts of a functioning energy or navigation system, we would expect some consistent engineering signature, not merely impressive construction, but repeatable technical markers. Standardized conductive materials, compatible layouts, evidence of transmission or reception equipment, maintenance traces, operating residues, inscriptions describing use, or at least a distribution pattern that cannot be explained by geography, religion, politics, or independent development. Instead, the proposed grid is usually assembled after the fact. Sites are selected because they are famous, strange, old, or visually dramatic. The map is drawn around the mystery. That does not make the Great Pyramid less remarkable. If anything, separating it from the Anunnaki grid may allow us to see it more clearly. It does not need alien sponsorship to be astonishing. Its difficulty is enough. Its endurance is enough. Its mathematical and architectural discipline is enough. The question is not whether ancient people were capable of genius. They plainly were. The real challenge is resisting the urge to turn every unexplained detail into evidence for the same predetermined story. There is a revealing irony here. The power plant theory tries to make the pyramid more technical, more advanced, more modern. The Anunnaki theory pushes that further, turning human monuments into traces of a cosmic infrastructure. But the more universal the explanation becomes, the less it belongs to Egypt. Khufu's pyramid becomes a prop in someone else's mythology. Mesopotamian gods are removed from their temples and reassigned to spacecraft. Many civilizations are blended into one imagined operating system. The result is dramatic, but not especially faithful to the ancient world. What we can say with more confidence is this: the Great Pyramid has become a meeting place for many modern desires. The desire for lost knowledge, the desire for contact, the desire to believe that our ancestors were closer to the stars than textbooks allow, the desire to suspect that the official story is incomplete. Some of those desires are not foolish. History is incomplete. Archaeology does revise itself. Ancient people did know things that modern observers have underestimated. But mystery is not a blank check. It asks for patience, not just imagination. The Anunnaki connection and the global grid idea reveal less about the pyramid's original function than about the modern myth growing around it. They show how a monument can become too large for one civilization in the public imagination. It begins as Egyptian stone, then becomes Atlantean memory, alien beacon, power station, harmonic engine, and planetary node. Each generation adds a new layer, using the language it understands best. And perhaps that is the strangest energy the pyramid produces. Not electricity, not microwaves, not signals to orbit, but interpretation. An inexhaustible current of human meaning, moving through fear, wonder, suspicion, and awe. The strange thing about the Great Pyramid power plant theory is not simply that people believe it. The stranger thing is how naturally the idea seems to attach itself to the monument. Most ancient structures require effort to turn them into machines. You have to stretch the evidence, import outside myths, ignore inconvenient details, and ask the viewer to squint a little. But the Great Pyramid almost invites mechanical imagination. It has passages that feel too narrow to be ceremonial in any ordinary sense. It has chambers placed with a severity that looks almost diagrammatic. It contains granite hauled from far away, set deep inside limestone mass, with joints so close they still trouble anyone who has tried to understand the practical realities of building it. It has shafts that point toward the sky, hidden spaces, sealed features, unusual acoustics, and a geometry that seems to ask for measurement. To a modern mind, trained to see design as function, this is almost irresistible. We live surrounded by machines that hide their purpose inside clean surfaces. A phone gives no hint of its inner circuitry. A power station, seen from a distance, can look like a temple to steam and metal. Even a radio antenna, to someone unfamiliar with electricity, might appear as an abstract object with no obvious practical use. So when people enter the mental architecture of the Great Pyramid, they often bring a modern instinct with them. If something is precise, if something is difficult, if something is hidden, then perhaps it is technical. That instinct is not foolish. It is part of how human beings learn. The problem begins when the instinct becomes a conclusion. The pyramid power plant idea survives because it offers a feeling that conventional archaeology often struggles to provide. The feeling of recovering a lost operating manual for the ancient world. It suggests that the monument is not only impressive, but usable. Not merely symbolic, but active. Not a royal tomb, or a sacred landscape feature, or a statement of divine kingship, but a device, a system, a piece of technology whose meaning was not buried with Khufu, but misread by everyone who came after. There is a deep emotional charge in that possibility. It turns the viewer from a spectator into an investigator. Suddenly, every passage may have a hidden function. Every chamber becomes a component. Every material choice becomes a clue. The king's chamber is no longer only a solemn granite room. It becomes a resonator. The shafts are no longer symbolic openings toward celestial regions. They become conduits, waveguides, or vents. The pyramid's mass is no longer an overwhelming architectural achievement. It becomes an engineered shell, a casing around some vanished process. This is why the theory has such endurance. It gives purpose to oddness, and the Great Pyramid contains enough oddness to keep the imagination fed for generations. There is also a quieter reason the theory refuses to die. The accepted explanation, though supported by a large body of archaeological context, is not emotionally tidy. The Great Pyramid is generally understood as a Fourth Dynasty royal monument, part of a broader Egyptian funerary and ideological world. That explanation connects it to kingship, labor organization, quarrying, ritual, solar religion, and the political theology of ancient Egypt. But it does not answer every practical question in a way that satisfies modern curiosity. It does not tell us exactly how every block was moved, how every internal decision was made, or why certain architectural choices took the precise form they did. Archaeology often works with probabilities, comparisons, surviving traces, and the slow accumulation of context. Alternative theories often work with sharper lines. They can say, this was the purpose, this was the mechanism, this was the lost science. Even when the evidence is thinner, the story can feel more complete. That completeness is powerful. A machine theory gives the pyramid a plot. It starts with hidden knowledge, moves through technical design, passes through catastrophe or loss, and ends with modern rediscovery. It has drama built into it. The conventional story, by contrast, asks for patience. It asks us to care about administrative capacity, religious symbolism, quarry logistics, and the worldview of a civilization very different from our own. Those things are fascinating, but they do not always produce the sudden electric thrill of, what if this was never a tomb at all? There is a kind of modern loneliness behind some of these theories, too. Many people sense that something has been lost between ancient life and technological modernity. We have more information than any society in history, and yet we often feel less connected to the sky, the land, and the deep rhythms of time. Ancient monuments seem to come from a world where architecture, astronomy, religion, and political power were not separated into neat categories. The pyramid stands at the crossing point of earth and stars, geometry and death, labor and divinity. The power plant theory takes that feeling of lost connection and translates it into energy. Not spiritual energy, but literal energy. Electricity, frequencies, resonance, wireless transmission. The language changes, but the longing underneath remains familiar. Perhaps the ancients knew how to live in tune with forces we have forgotten. Perhaps modern civilization, for all its devices, is not the peak of understanding. Perhaps progress is not a straight road upward, but a broken chain, with missing links buried under sand and stone. This is why the theory often blends so easily with ideas about suppressed technology. Once the pyramid is imagined as a generator, it is only a short step to ask why its secret disappeared. Was it forgotten? Deliberately hidden? Destroyed? Misinterpreted by priests, conquerors, or later scholars? Here, the evidence usually grows very thin, but the narrative appeal grows stronger. A lost technology is interesting. A suppressed lost technology is captivating. It also reflects a real suspicion of institutions. Museums, universities, and archaeological authorities are often seen by enthusiasts as gatekeepers, too cautious or too proud to admit radical possibilities. Sometimes this suspicion is unfair. Serious archaeologists revise their views constantly when evidence demands it, though rarely with the theatrical speed that television prefers. But the distrust does not arise from nowhere. Academic language can feel distant. Excavation reports can be inaccessible. Public explanations may simplify complex debates. Into that gap, alternative theories enter with confidence, vivid diagrams, and the promise that the ordinary viewer can see what experts have missed. There is an irony here. The power plant theory presents itself as a challenge to mystery, but it survives because of mystery. If every chamber had been found intact with clear inscriptions explaining its purpose, if every construction stage were documented in detail, if the original casing and surrounding complex had survived untouched, there would be less room for reinvention. Instead, the pyramid comes to us incomplete, robbed in antiquity, entered and re-entered, studied through centuries of changing assumptions, stripped of much of its outer casing, separated in the popular imagination from the wider religious and funerary landscape around it. A monument with gaps becomes a mirror. People do not only see ancient Egypt in it, they see the anxieties of their own age. In the 19th century, some saw sacred measurements and biblical chronology. In the 20th century, others saw radio, vibration, nuclear hints, or lost sciences. In the age of wireless networks and invisible signals passing through the air, the pyramid becomes easier to imagine as a transmitter. In a world facing energy crises, the dream of clean, ancient power becomes especially attractive. The theory changes costume as modern technology changes around it. That does not make every claim false by association. It does mean we should notice how often the pyramid is recruited to answer contemporary desires. The best alternative theories usually begin with a legitimate observation. Granite does contain quartz. Resonance is real. Hydrogen can be produced chemically. Shapes can affect electromagnetic behavior under certain conditions. Ancient Egyptian engineering was extraordinary. None of these points is absurd on its own. The difficulty lies in the leap from isolated scientific facts to a complete ancient industrial system. A property of a material is not proof of its intended use. A possible reaction is not proof of a chemical plant. A chamber that resonates is not automatically a power amplifier. A shaft that aligns or channels air is not necessarily a technical conduit. But the leap is seductive because it feels like synthesis. It gathers scattered details and makes them cooperate. That is one reason debunking rarely ends the discussion. A skeptic may show that the evidence for electricity is absent, that no machinery has been found, that the chemical model lacks residue, that the historical context points elsewhere. These are serious objections. Yet for believers, the theory may not rest on one piece of evidence. It rests on a pattern they feel they can see. Remove one element, and another remains. The precision, the granite, the shafts, the scale, the astronomy, the missing capstone, the hidden chambers. The argument becomes less like a bridge, where one broken support can matter, and more like a web. Cut one strand, and the shape still hangs in the mind. There is also the simple fact that the Great Pyramid is genuinely difficult to reduce to ordinary language. To say it was a tomb may be broadly correct within the accepted framework, but the word tomb can sound too small. It suggests a grave, perhaps a chamber, perhaps a memorial. The Great Pyramid was part of something larger, a cosmic statement in stone, a royal transformation machine in the religious sense, a monument that linked the king to eternity through architecture. If modern audiences hear only tomb, they may assume archaeologists are offering a dull explanation for an astonishing object. That misunderstanding leaves space for mechanical theories to feel more respectful of the pyramid's grandeur. In a way, the power plant theory is a modern myth about ancient intelligence. Not myth as in simple falsehood, but myth as a story that organizes wonder. It tells us that the past may contain a higher science. It tells us that official explanations may be incomplete. It tells us that stone can remember what texts have lost. And it places us, the viewers, in the role of those standing at the edge of revelation, listening for a signal still humming beneath the desert. The responsible position is not to mock that sense of wonder. Wonder is often the beginning of knowledge. The danger comes when wonder is asked to do the work of evidence. The Great Pyramid does not need to be a power plant to be mysterious. It does not need hidden circuitry to be intelligent. Its builders already commanded an astonishing mastery of planning, labor, materials, astronomy, ritual meaning, and state organization. If anything, imagining it only as a machine may narrow its strangeness. Machines have users. They have outputs. They can be explained by function. The pyramid belongs to a world where function and meaning were intertwined in ways we are still trying to understand. That may be the deeper reason the theory refuses to die. The pyramid sits between categories. It is mathematical, but not merely mathematical. Religious, but not merely religious. Political, but not merely political. Engineered, but not an engine in any proven sense. It is precise enough to provoke technical theories and ancient enough to resist modern certainty. So the idea returns, again and again, not because it has been proven, but because it gives modern imagination a way to touch the impossible scale of the thing. The theory is a response to awe, dressed in the language of physics, and under the desert night, that awe is still there.